In lab 3, we're measuring the distances between the sensor and the magnet at different given magnetic fields, the XYZ components of the fields, and compare the measurements to the values calculated by the equation derived from Biot-Savart law. Lab goals 1. To find out the distance dependence of the bar magnet. 2. Compare the obtained values to the theoretical values to check if there's any systematic or random error. 3. Using the spreadsheet, compare the values of b-axis, b-perp in each cases, and also b45 degree after we done the code. Physics principle used. In this lab, the main physics theorem that we are applying is the Biot-Savart law. Through measuring the magnetic field in different distances, we will be able to calculate m, which is the distance dependence coefficient. Also, the below equation was provided for calculation. The magnetic field B created by the dipole with magnetic moment mu at an observation location R relative to the dipole. Lab procedure 1. Obtain the magnetic field from the website for my location. 2. Align the phone to the ruler. 3. After finishing the setup steps, we measure the distance from the magnet to the sensor at each net field indicated from the instruction. 4. We measure the perpendicular ones, with first measuring the d-perp, which is the distance perpendicular to the sensor in b-wires. Then we add another ruler to measure the field along the line 45 degrees to the axis. 5. After we obtain all those data, we put them into Excel spreadsheet so it will return us a best fit line function that shows k and n. So here's my Excel spreadsheet data. The distance dependence coefficient n is equal to negative 2.6, and the error percentage is 13.22. Yeah, so that's an acceptable range, I guess. This part is the second part of the lab where we measured the perpendicular field and the 45-degree ones. So here's my glow script code. I divided them into parts so it's easier for you to see what I did. So in this part, I basically put the dipole moment value and I scaled the arrows, and I created a function for magnetic field. So in these two parts, it shows the fields like magnitude and also the arrows representing the fields. So here's my result. So as you can see, all my results are here. If we hadn't oriented the bar magnet to the magnetic north, the total magnetic field would be the sum of the bar magnet's field and the Earth's field, but in this experiment, we're only focusing on the bar magnet. The results would be the same since it's still a magnet. Magnetic fields won't change in this case. Thanks for watching and have a great day.